Hello and welcome to our fourth set of notes for college algebra. We're going to keep working with some straight lines today. We saw straight lines last time. We introduced like linear functions, the idea of slope. We saw the slope-intercept equation, which we'll use for the first couple pages here. So let's just write that down again. Remember the slope-intercept equation is that y equals mx plus b. And we'll use that as much as we can because it's a nice way to write an equation of a line. It's really convenient to have an equation of a line written this way. So if anybody ever wants you to write an equation of a line and they give you good information like the slope and the y-intercept, it's pretty straightforward. You can really just write this equation. So that's what this first page is going to do. They're going to give us slope and the y-intercept, and we're going to write the equation of a line using that. Remember that the slope is m, so when we talk about m, we're talking about the slope or vice versa, and that b is the y-intercept. It's where it crosses that y-axis on the graph. So if someone comes along and gives us this point and this slope, well, we're really excited. They made our life really easy because they gave us the slope, so we have m, and this point right here, this -3, is our y-intercept. Now, how do I know that's the y-intercept just by looking at this point? Well, notice that the x is 0. Remember that if you have your xy graph, if your x value is 0, well, you're going to be in the middle of the graph. So this 0, -3 is actually a mark down here, down at -3, and that tells us that we're actually on the y-axis. So this is b. This is our y-intercept. So anytime they give you a point and the x value is 0, then the y value is b. So really straightforward. We can write the equation really easily. We just write y equals, put in the m, which is 2/3. They told us our slope is 2/3. X, don't forget the x part, plus b. Well, since this is plus a -3, we're just going to write that as -3. And that's it. If they give you the intercept and the slope, it's pretty straightforward. There's not a whole lot of work to do here because they gave us m and they gave us b, and we just put them in. So if that happens, yeah, life is pretty straightforward, pretty easy, nice to do. And that's what they're going to do in the next one too. So again, x is 0. As soon as x is 0, we know that this other value is our b. It's our intercept. And again, they gave us the slope. So if they give you the slope and they give you the intercept, we use that y equals mx plus b, this equation. And we write y equals slope 7, x, don't forget the x, you need that x in there, plus b, well this time b is 5/8 because that's our intercept, so 5/8 is the intercept. And that's it, done. We'll do one more that's this straightforward, hopefully this straightforward, but that's the idea. If they give you slope and intercept, especially the y-intercept like that, pretty straightforward. So this last one, they gave us a intercept, right? Because again, x is 0, as soon as x is 0, we know that this b value, this y value is our b, it's our intercept. Because x is 0, that's our intercept. Over here, slope is 0, so the slope is 0 on this one. So they gave us a slope, gave us the intercept, we write our equation. We write y equals 0, x plus 9, but that's our intercept. But of course, this one, you're not going to type it like this into my math lab. If you put that in my lab, it'd probably count this wrong because it's going to say, well, why would you put 0x? Everybody knows that when you multiply 0 times something, it goes away. 0 gets rid of the x, it gets rid of all that, it just becomes nothing. So we don't need the 0. So we actually just write this as y equals 9. Remember, m equals 0. This is a 0 slope. This is a horizontal line, right? 0 slope always makes that horizontal line. And so we knew it was going to be a line like this. So we said that when it's a horizontal line, it's always y equals a number. Because the number 9 just tells you how high to put that on your xy graph. So if you have an xy graph like this 9 is how high this line would be. So y equals 9 just tells us how high to put that horizontal line. So if you ever have a slope of 0, you know it's going to be like this. If they had told us slope was undefined, then we would have had x equals a number. That can't quite be written in the y equals form, so that'd just be x equals if we had it undefined. I think that's why we're sticking kind of more with stuff with slopes, because then you can write it as y equals. But if they ever do want you to do something undefined, remember that's x equals the number, because that's when you get a vertical line. Okay, well now real life isn't always this easy, right? They were giving us these nice intercepts every single time, and that doesn't always happen. So what if they give me the slope, but just some random point, not the nice y-intercept. Well, in that case, I actually go to my backup equation. So there's actually two different ways to do the equation of a line. My backup equation, I really like this equation, it's called the point slope equation. A lot of people forget about this equation. I don't think it's nearly as well known because most people, if they can, would prefer to work with a slope intercept. It's a little more straightforward. This equation, though, this works for slope and any point. So the point that we're working with now doesn't have to be an intercept. It just has to be a point on the line. It could be any point on the line and the slope, and it will give the equation. One problem with this equation is because it works with any point, it can look different depending on which point you use. So if you have two different points that are on the same line and use them to make this equation, use one for the one version, one for the other version, they're going to look different. It's going to look like you have two different equations. So I think that might be one reason why people like the y equals mx plus b, that slope intercept, because it always looks the same if you're doing the same line, because you're always using the same slope and the same intercept for that line. Okay, so we're going to use this point slope. Now, we'll go ahead and we'll get the equation in point slope form using the point they give us and the slope. So like this first one, they give us a point and they give us a slope. And this point, notice, is not an intercept. There's no 0. Again, you have to have a 0 for x to be the intercept. So I can't use this to do slope intercept, but I can use it for point sloped. So to do point slope, what I do, the y and the x never change. You always have to have a y and an x in the equation, just like the y equals mx plus b has a y and an x. So those don't change. I'm going to leave that as a y. But the y1 and the x1, that's what you replace these numbers with. So the 3 is going to be my x1, the negative 4 is going to be my y1, always xy when you do points. So this negative 4 is going to go in for the y1. Now there's a minus here already, so when I do a minus minus, double negative, remember double negative makes it a positive, so this becomes y plus 4. Because there's a negative built into the equation, the extra negative on the 4 turns it back into a plus, because two negatives make a plus. Okay, bring down your equals, bring down your slope, which is 2/3. Parentheses, x, again, we don't change the y or the x, we always change the y1 and the x1. Put a minus in there, x minus x1, which is 3, and that's your point slope equation. So this is point slope. So this is the equation of this line. You could use this equation to graph this line. I mean, remember we did the xy pairs, the tree. You could do that. You could make a little tree and graph this, and it would give you the equation, the graph of this line. This is the equation for the line. But the problem is this equation, again, it's not unique. There's lots of different ways we could write this to get, this equation, depending on different points. The other problem is it's not great for the calculator. If you're going to use a program or a calculator, they like to have it solved for a y to be able to graph it. So a lot of times we're not going to stop here. We'll get point slope equation. It gives us an equation, which is awesome. But then our last step will be getting the slope intercept form. So I'm going to go ahead and take this and get slope intercept form. And the nice thing is all you have to do to get slope intercept form is you have to get the y by itself. So we want y equals, and get rid of the parentheses, because we don't want any parentheses in slope intercept form, right? The slope intercept form, remember, y equals mx plus b. Doesn't have any parentheses, just has an mx plus b, that's it. So that's what we're going to do. We're going to distribute. I'm going to multiply this 2/3 to both parts, because I'll get rid of the parentheses. Remember distribution where you multiply to both parts. 2/3 of x is 2/3 x. You can't multiply because we don't know what x is, so we'll just leave it like that, multiplied. 2/3 times 3. Remember when you multiply a whole number in a fraction, you can always think of a 1 on the bottom. I never actually write the 1 because 1 times the bottom isn't going to change anything, so I know it's just going to be a 3 on the bottom. So I would write that as, 3 times 2 is 6 over 3, but 6/3 simplifies to 2, so I'm going to put minus 2. Now, I don't care how you do that. You can do this in your head. You can do it on paper. You can write down, 2/3 times 3 over 1. And remember that when you multiply 2 times 3, you get 6. 3 times 1, you get 3. And then that divides to give you 2. Or you can even make your calculator do that. If you don't like doing fractions, this calculator, the T84 or T83, whichever one you have, it does fractions. You can actually take 2 divided by 3 times -3. I'm going to call that a -3 so I get the right sign. I'm going to hit enter. Now it does give you -2. Now if even if it doesn't work and give you a whole number, sometimes they'll give you decimals. The math button right here actually has a very first option is turn something back into a fraction. So if you've ever got one that's not going to be a nice whole number, one that's a decimal, the The first option, you just hit enter and you hit enter again, and it'll turn into a fraction. This is a bad example because negative 2 is already whole. But you can use your calculator through these fractions. That's something I always like to point out, that those calculators are built so that you can do fractions. All right, so that distributed there. The next thing we need to do is we don't want this plus 4 on the left side because we want to get the y by itself. So I'm going to take this and subtract 4 from both sides. So I'm going to subtract 4, which means I have to subtract 4 in this next row because I write my new row. But on the left side, that 4 is gone. So I'm just left with this y. Okay, now to finish this off, okay, I have two numbers here hanging out at the end, so I got to combine those. Negative 2 minus 4, combine those, you get minus 6. So 2/3 x minus 6. That gives us y. That's what we're looking for. This is the slope-intercept form, right? Because it gives us our slope, it gives us an intercept. That's what we're looking for. We like that slope-intercept form. So there it is. So you can always take point-slope form. You can always get slope-intercept. You just distribute, move whatever numbers on the wrong side across, combine like terms like that, and that always works. That gives you that slope-intercept form. Okay, let's try the next one. Same thing. They gave us a point, and they gave us a slope. Again, that's nice. They gave us a slope, and they gave us the point, but the point they gave us is not the intercept. So to use these, I have to use that point-slope form. I do y minus the y1, which is going to be the 5. So y minus 5 equals slope, which is negative 3/4. X minus the x1, well, minus the negative 1. Again, when you double negative, you get a plus. So when you're doing point-slope form like this, you know that the negatives cause pluses because of double negative, and the positives, they'll just stay minus because of the minus built into the equation. That's our point-slope form again. That's point-slope. Versus when we solved on the other one, we had that slope-intercept. So again, what we want to do is we want to take this and get slope-intercept. So we're going to distribute, we're going to multiply that negative 3/4 through across. We're going to add 5 to both sides. That way we can get the y by itself, because we got rid of the minus 5 over here. Negative 3/4 times x, well, it just stays negative 3/4 x, because we can't finish multiplying because we don't know what x is. Negative 3/4 times 1 gives me a negative 3/4. And then don't forget you have to add 5. And this is probably where you're better off using your calculator. So if you don't want to do this by hand, you can type in negative 3 divided by 4. So I type a fraction on this calculator, negative 3 divided by 4, plus 5. And it'll give me my answer. Now it's in decimal. Again, that's why I use the math button. Hit enter twice. Once to put it on there, once to do it. And you can see the answer actually is 17/4. So my final answer for this one would be y equals negative 3/4 x plus 17/4. And if you want to see how that works, you can always do this negative 3/4 plus 5 and, on your own, without a calculator. Just get common denominators. Remember, you have to get matching denominators before you can add with fractions. If you don't want to do common denominators, your calculator can do some of that stuff for you right now. Later we'll see some stuff where you kind of have to deal with the common denominators because, well, I'm going to throw some letters in the bottom and stuff. But for now, we could make life a little bit easier. We could say, okay, well, I don't want to try and deal with fractions. I can make my calculator do that kind of math for you. Okay, let's do one more of these. Now this one's a little different. Hopefully you notice what's different. Other two we had gave us slope, right? They gave us m. This one doesn't give us slope. They gave us 2 points, but they didn't give us slope. So what do I do if I have 2 points and no slope? Well, thankfully, we have the slope formula. Remember the slope formula? The slope formula says that m, the slope, is equal to y2 minus y1 over x2 minus x1. So we can actually find the slope ourselves. That's the big trick here. If they ever give you 2 points and don't give you slope, that's not a big deal. You have a formula for finding slope. So you just take the 2 points and find your slope yourself. So I'm going to take these two. I'll throw this my y2, x2 over here, x2, y2. So negative 4, my y2. This will be my y1, so I subtract 7, so that's my y1. On the bottom I'll have x2, which is negative 9, minus x1, which is negative 2. And that will give me my slope. So I'll simplify. Again, a double negative is always a plus. So I think about this, and I like to think about subtracting with negatives as adding the opposite. I like to add instead of subtract. It makes my life a little easier. So negative 4 plus negative 7 is negative 11. Negative 9 plus 2, well, that cancels 2 of the 9s. We'll end up with negative 7. And of course, if you divide a negative by a negative, you always get a positive, right? Just like when you multiply a negative times a negative, a double negative makes a positive, so this becomes 11/7. That's our slope. So now that we have the slope, now we can use that point slope form. Remember, point slope form is great because you just need any point and the slope. So now that we have the slope, you know that that is m, that's our slope, then we can go back and use point slope form. Now, which point do we use? Well, the answer is it doesn't matter. Either point is going to give us an equation for the line. Either one of those we can go back and find slope intercept. So I usually try to pick whatever I think is going to be easier. It doesn't really matter. I might go with the first one just because there's a positive 7, both negatives, but it really doesn't matter. You can pick either point. So I'm going to do my y minus the y1. So I'm going to call 7 my y1 equals slope, which is 11/7. That's my slope. X minus the -2, but if you subtract a negative, it's like you add, right? Double negative is an adding, and that's our point slope equation. So this is the point slope. But again, these problems a lot of times want you to write with slope intercept. One of the ways they make you, solve the problems and give a slope intercept answer without even telling you that is they might just give you a y equals. And of course, if it starts with a y equals, it's got to be in this form. So if you ever see a y equals before your box, you know you're going to write it like y equals it's supposed to be. Okay, so that's what we're going to do here. We want to write this as y equals. So again, to do that, we're going to distribute, and we're going to get rid of the 7. So we're going to add 7 to both sides. Again, we're always doing the opposite here to get rid of that number. So opposite of subtract 7 is add 7. Let's get y equals, this is 11/7 x. And if I do 2 times 11/7, 2 times the top, 7 times the imaginary 1 on the bottom we can put there, because we're always going to take a whole number and put a 1 on the bottom. 7 times 1 just stays 7. 11 times 2 gives me 22. And then don't forget there's still plus 7 we haven't done yet. So to finish this off, I need to add the 7. Again, you can type in your calculator, or if you like to do your own fractions, you can remember that 7 is the same as 49/7, because 7 times 7 is 49, so that's how we see this as 49/7. If you divide, you get 7. So if I take 22/7 plus 49/7, I get 71/7, right? 22 plus 49, 20 plus 40 is 60, 2 plus 9 is 11, so we get 71/7. Still that 11/7 x added to that equals y, and that would be our final answer. Slope intercept form. So you should be ready to write your answers in slope intercept form. You should know how to use that point slope equation. Both of those, both the slope intercept and the point slope equations, I did put them on the formula sheet. So I'm not expecting you to have all this stuff memorized. I'm not a big fan of memorizing math because Google exists, right? Wikipedia exists. So if you need to remember the point slope formula or the slope intercept formula, in real life you can Google it and find it really fast. So I think a formula sheet kind of makes sense because you basically all walk around with this phone, formula sheet access of Google all the time. But you do need to know how to use those formulas. And that's what's really important to me. So you should be able to plug in the proper numbers, find the slope when you need to, and then get that value in that nice form when it's ready to plug into calculators or use for other things. So slope intercept. Okay, now there's a little bit more to this section. The rest of the section is dealing with 2 special cases. Cases where instead of just giving you the slope, by giving you 2 points where you can find it, or just giving it to you outright, they're going to tell you how to figure out the slope for yourself by using a couple special key words. The first word is going to be parallel. So when you deal with parallel lines, hopefully you remember from grade school, parallel lines means railroad tracks, right? That's what you're thinking, you're doing railroad tracks. Because parallel lines are road lines that go next to each other and never cross, right? That's parallel lines. Well, for us in algebra, when we're graphing, parallel lines, what we think of them as is that they have the same slope. The picture over here shows this really well. These have the same slope. These are parallel lines. You can see, they'll never cross because they're just always the same distance away from each other. And that's what makes them parallel lines. And so parallel lines always have matching slopes. So what that means is if someone has an equation and they say your line or your equation is parallel to that equation, what they've really just done is told you the slope. You could just look at their line or the original line and say my slope has to be the same. So in this equation, the slope is 2, right? The slope is 2 here. Since our slope is the same, same slope because we're parallel, it means our slope is also going to be 2. We're going to have the exact same slope. So if I want to write the equation of this line over here, well, right now, because these are parallel, I know this has slope 2. Now, to write an equation, it's nice to know both the slope and the y-intercept. So let's go ahead and figure out the y-intercept. Well, thankfully, because they gave us the graph, it's really easy to find the y-intercept. You just look for where does it cross the y-axis, and it crosses at 4. So the y-intercept b is 4. So the equation of line L, this line L we're trying to find, is going to be y equals slope 2x plus b. Remember, y equals mx plus b. You know, you should really get familiar with that y equals mx plus b. I know it's on the formula sheet, but it just comes up all throughout the semester. So it's a good thing to be able to recognize, even without the formula sheet, is that when you see, you know, a number in front of the x like that, just a plain x and a plus number or minus a number, that's that slope-intercept form, and it gives you the equation for a nice straight line. So that's what that equation is. We use the same slope because parallel. So that's what this next two questions are going to do. They're going to use that parallel idea to get us the slope. So for the next one, it says that we're parallel to this line. Now that's not our line, right? They didn't give us this line to give us the final answer and we're done. We don't just get to write y equals 3x minus 1 and say we're done. No, they said write equation line that is parallel to this line and then goes through some other point. So it's not this line. This is not our line. But our line is parallel to that line. And so that's just a really fancy, silly kind of way to tell us that our line has the same slope as this line. And since this line has slope 3, because it's solved for y equals mx plus b, it's a nice, you know, solve, you can see that that's m, 3 is m, then our line has slope m. So same slope. So our slope is 3. Now, sadly though, not quite as easy as the first one because they didn't tell us the intercept, right? The first one we could see the intercept on the graph. This one, they don't tell us the intercept. Instead, they give us some random point. So again, we can't use this to get slope-intercept because it's not an intercept, but we can use it for that point slope. Y minus y1 equals m times x minus x1. So we can use that to get the equation that way, you know, using this point they gave us and the slope they gave us. Notice we're not going to use this minus 1 for anything because that's not our line, that's another line. The only thing that was good from that line was the slope because if it's parallel, it has to have the same slope. That's why we knew our slope was 3. So we're going to use the slope we figured out using the parallel factor and then the point they gave us, and we'll get our equation. So our equation is going to be y minus, our y1 is going to be this 4, so y minus 4 equals slope, which is 3, x minus x1, just this 2 here, so 2, and that's the equation of our line. So now we got an equation for our line. Again, if they want it in slope-intercept form, which they always do, because they want us to make sure we can get both point slope and slope-intercept form, we need to go back and we need to solve this for slope-intercept form. We need to get that distribution done, get rid of the parentheses, and we need to add 4 to both sides to get rid of this minus 4. So that way we can get the y by itself. Here we get 3x minus 6, right? Because 3 times 2 is 6. Then still plus 4. And now we can combine those two terms so we get y equals 3x minus 2. So same slope. If you graph both these lines on the calculator, you can graph both at the same time. You'll see they have the same slope. They won't cross. And they have different intercepts because they're not the same line. And so that's why this one is our answer. If you graph this one, you could check 2, 4 will be a point on the graph. That's another way to check these. That's the nice thing about a lot of these graphing problems. If you really want to go back, you can double check yourself. You can type the equation in the graph and see, did I do it right? Does it make sense? You know, if I look at it, does it have a point 2, 4? If I look over here, I go 1, 2, up 4. Yep, that's right. You can use the trace key. So you can use the trace key on here. It puts a little marker on the line, and you can type in what you want x to be. So I'm going to type in 2 from the x, because this said x is 2. And see what the y is. The y is 4. So at 2 I get 4. So there it is right there. So yeah, that point's on there. If I graph the other equation, the 3x minus 1, it should be parallel, right? So I can go back and I can double check those kind of things. And I can see that, yep, those two lines, they never quite touch, right? They're always a little bit spaced apart. So you can double check yourself. It's nice when you're working with equations, when you're working with stuff you can graph it, see if it worked. Did it make sense? It's a great way to double check. Still important to be able to solve the problem because it's hard to get this equation to check without, solving it. So you want to be able to solve it. But graph is a great way to check. Okay, I'm going to do one more like this. So one more where they say find the equation that's parallel. It'll give us this line. And then again, that it passes through some other point. So we're going to tell us it passes through some other point. And they do want it both in point slope and slope intercept. So we're going to do both point slope and slope intercept again. Now first off, you'll notice this equation, the slope is not 3. Now why is not the slope 3? Why is it 3? Because this one's not solved for y. It's not written in y equals mx plus b form. So this one, we can't tell what the slope is. The only time you can tell what the slope is if it's in that y equals mx plus b form, or I guess if maybe it was in like point slope form, you could figure it out. But that's still kind of hard. So we usually like to have it in that slope intercept form, because that's really easy. So something like this, first thing we're going to do is going to solve for y. Because if we solve this equation for y, then we can get an idea about what the real slope is. So I'm going to take that 3x minus 2y equals 11. I'm going to solve this for y. So first thing, I want to get rid of this 3x. I'm going to subtract 3x from both sides. I'm just trying to get this side empty, so I just have the negative 2y left. So negative 2y equals, I'm going to put this as negative 3x plus 11. So I like the x in the front. It's closer to the mx plus b format. Next thing I need to do, I need to get y by itself, so I need to undo this multiplication. So I'm going to divide both sides by negative 2. When you divide both sides, don't forget to divide everything on both sides. On the left side, the negative 2's cancel, because we multiply by negative 2, divide by negative 2. That cancels, it gives us y by itself. On the right side here, we have to divide both of these by negative 2. Well, negative 3 divided by negative 2, negative makes a positive, and 3 doesn't divide by 2, so we'll leave it as a fraction. We'll leave that as 3 halves. Don't forget the x. 11 divides by 2 gives us 11 halves, and a positive divided by negative is a negative. I really don't care too much about this part, because what I really care about is this guy right here, because again, that is my slope. Remember that parallel means same slope. So all that work was just to figure out what the slope is. Since they didn't give us a nice version of their line, we had to get our own nice slope-intercept version. Now we can know what the slope is. Now we're ready to use that and go and figure out what our equation is. Okay, to use our equation, we're going to use this point they gave us and the slope we just found and do that point slope equation again. So we're going to do y minus y1, so y minus 5 equals slope, which is 3 halves, x minus the negative 1, so plus 1. And that's our point slope form, right? So again, point slope form using the point and the slope. And then to get slope intercept, we're going to distribute and we're going to add 5 to both sides. So that's how we can get that solve for y. 3 halves of x is just 3 halves x still. 3 halves of 1, that's 3 halves. And I add 5. 5 is 10 halves, so if I add that up, I get 13 halves. So 3 halves of x plus 13 halves is equal to y. That is our equation. Again, it's got the same slope. It's got 3 halves slope, but a different intercept, so it's a different line. If you graph this, it'll cross through the point, negative 1, 5. Okay, we're ready for the last page. The last page on this, we're just going to take this and we're going to deal with perpendicular lines instead of parallel. So instead of perpendicular lines where the lines are running along each other, we want perpendicular. Remember, perpendicular means they make a nice right angle. You usually use the little box for right angle as a 90 degrees angle. That's what perpendicular lines do. Perpendicular lines make a right angle. Now, how does that translate to our graphs? What does that look like for graphs? Well, for graphs, if they're going to make a nice right angle, they're going to have to be going the different directions. So if one's going up to the right, or positive direction, the other one's going to have to go down to the right, or negative direction. If they're both going positive, they're not going to make a right angle. So if you think of like my 2 pens, they're both going positive, you see how they're never going to make a right angle if they're both going positive. In order to get a right angle, I have to move this in so much that now it's going negative. So now they're a right angle because I made one negative. So if they're both positive, they're not going to make a right angle. So one thing, if you want perpendicular lines, the slopes have to be negative of each other. If one's positive, the other one's negative, and vice versa. If one's negative, the other one's positive. And then also, if one is really steep, so say this is like 5, it's very steep, the other one's going to be fairly flat. It'd be closer to like 1/5 than 5. So actually what you have to do to make them so that they cross nicely and aren't both steep, so that they're not 90, is you have to make them the reciprocal of each other. Remember, reciprocal is just a fancy way of saying take the fraction and flip it over. So to be opposite slopes, to make a nice 90-degree angle, you have to have the negative reciprocal. So for example, this line right here has slope 1/2. That's what this slope is right here. It's going up 1 over 2, 1, 2. That's the slope of 1/2. To get the negative reciprocal, we're going to take this 1/2, we're going to flip it over, so it's 2 over 1, and make it the negative. Since this is positive, we'll get the negative. So the slope of our line, our slope, the slope of L, is negative 2 over 1, or you can just simplify that to negative 2. That's the slope. Because you flipped it over and changed the sign. And that's how we got the negative 2. So this one, you can see the other line, line L, if you go down 2 and over 1, negative 2 over 1, that's its slope, right? Negative 2 over 1. So slopes for perpendicular, and perpendicular always means flip it over and change the sign. It's the negative reciprocal. Okay, we wanted to get the line, equation of this line L. It does tell us to write the equation of line L. So we're going to use that intercept up here. This is our intercept, where it intercepts the y-axis. So to get the equation, we're going to use the y equals mx plus b. Slope we just figured out was negative 2, so it's going to equal negative 2 for x, for m, and then don't forget to write the x. And then the b intercept is 5. So that is the equation for line L, right there. Line L is y equals negative 2x is 5. That's the equation. So that's the thing. If you're doing perpendicular, the slope they give you, you take it, you flip it upside down, you change the sign. And now you have your slope. Okay, we'll do 2 with this one, and then we'll be done for this section. That's what I have to do. So I got a perpendicular to this equation. Thankfully, this time it's in that y equals mx plus b, so we can deal with it as it is. And then they tell us we want to be through a point here for our line. Okay, so first off, their slope is negative 1/3. That's what their slope is negative 1/3. So our slope, the slope for our line, our slope is going to be the reciprocal. Flip that over, you get positive 3. So change the sign and flip it over. So 3 over 1 just becomes 3, and the opposite of the negative is a positive. That's our slope. This is our point, x1, y1. So to get the equation, we're going to do that point slope form again. We're going to do that y minus y1 equals m x minus x1, and that'll give us our equation. So we do y minus negative 2, so minus a negative 2 gives us plus 2. Slope is 3. X minus x1 is 3. And that's our equation. Then we take that equation just like before. We're going to try and solve it for slope-intercept form. So I'm going to distribute my 3. I'm going to subtract 2 from both sides. Just working to get that y by itself. So y equals 3 times x is 3x. 3 times 3 is negative 9. 3 times 3 is 9. And then we still have to subtract 2. So the last thing I do is subtract those. So get y equals 3x minus 11. And that is the slope-intercept version of that line. Again, it's negative reciprocal, so the slope now is the opposite. I don't like to just say just opposite because people think I just switched the sign, but we switched the sign and we flipped it over, right? We did both. We did the negative and the reciprocal. We flipped it over and we changed the sign. And that's how we got the slope of our line. To be perpendicular, the slope has to be completely different. Okay, this last one is kind of a weird homework question that stumbles up a lot of people. I want to just help you out with it real quick. So here, this one wants us to find the line that's perpendicular to x equals 2. Wait a second. Does this even have a slope? X equals 2? What's the slope? Well, hopefully you recognize this. You say, oh yeah, whenever we had a line that's x equals a number, we said that that's going to be a vertical line, right? This is a vertical line. And we said vertical lines, the slope is undefined, right? Undefined is what we call it when it's straight up and down. Now you can't take undefined and flip it upside down and change the sign. That doesn't work, right? You can't change the sign and flip it upside down because undefined is not a number. It doesn't work that way. But you can remember that for two lines to be perpendicular, they have to make a right angle. And that tells us that the line that's going to be perpendicular with this line is going to have 0 for the slope. So that tells us that our slope for this problem, our slope is going to be 0. That's our slope. So that's the trick with this one. Our slope is 0 because their line was undefined. Now you could, at this point, go back and use that point slope form and plug in the point they gave us and plug in the slope we just figured out was 0. And you could solve it for y equals and get the slope intercept and all that. Or you can save yourself a lot of time and effort because we know that this line is horizontal and it goes through this point, -3, 4. Well, we know if it goes through this point that it's got to be 4 high, right? This right here tells us the height of the line is 4. And if it's a horizontal line and never it goes up or down, it has to always be 4 high. So we know that this one actually, this line with 0 slope that's 4 high is going to cross the y-axis at 4. And so it's going to be the value y equals 4. If you think about it, the slope is 0. So if you put a 0x in here, that would go away. And it would cross at 4, because it does cross at 4 at like, what, -3, 4? And it has to be perfectly horizontal. That's the line y equals 4. So we used the fact that it was going to be 4 high there, the fact that the slope is 0, so it's horizontal, and that's how we figured out what the line looks like. So it's y equals 4. As soon as you have a x equals number, you think in perpendicular, that's a vertical, you know that your horizontal is going to be y equals a number. And vice versa. If you had y equals 4, well, the perpendicular to that would be x equals a number. And again, the point they give you can just tell you what the number is. Since the height is 4, y is 4 in the answer. So we got that, and we're done. Okay, hopefully this helps you get through that outcome 4, homework 4. So that's it for this section. It's all about these straight lines. We are kind of done with these straight lines. We'll see them pop up throughout the rest of the semester, but from here on out, we get to move into maybe some solving more equations and stuff, or is what we'll see next. So, as always, if you're having trouble with this, if you're needing help, make sure you email me. Use that Ask My Instructor button. It's a great way to get homework help. And I'm also always happy to help with the quizzes and stuff too. So make sure you reach out if you're having trouble, if you need help with any of this material. I'd be happy to help. So, all right, until next time.